Everyone, and welcome to the presentation for temporal patterns in European football statistics from the year 2016 to the year 2023. So this is a presentation for the course of Time Series Processing and Analysis for the Masters in Artificial Intelligence and Data Analysis. I am Hugo Lopez. I am the single member of the group 10, which is an individual group. So without further ado, let's get started with the presentation. A little bit of background before starting to talk about the dataset selection is that I am a bachelor's degree in computer sciences, and I've been working mostly as a developer, so I'm really not into the world of data analysis, data sets, and everything. So I wanted to get a dataset that can be useful for me and for the purpose of this course and this presentation, and also something that had a big amount of data that I can use, and that will be one of the best options for me. So I went into the Kaggle website, and I searched for databases that had a big amount of data in order to analyze them, and I found this European soccer database, which I think it's interesting because soccer is one of the most popular sports in the entire world, and it surely will have a lot of data that I can work with. So the dataset that I selected is a reliable source in research and contains records of matches, teams, goals, and more across the different seasons of the European soccer in those years. The motivation is because it is ideal for time series analysis. So moving on, the selected variable that I am working with is the goals per match. And why did I select the goals scored per match? Because it is a simple metric, and it is relevant, and it represents a key indicator of the performance of those teams in this sport, and is also enough to allow the temporal analysis. The advantages that I have by selecting goals per match are that it has a bounding scale from 0 up to almost 6 goals in every match, and it makes the interpolation and modeling of the data easier, and is directly related to the outcomes of the match. The specific team that I selected for this analysis is the FC Barcelona, which is one of the teams that has a large volume of data in this dataset, and also has consistent participation across all seasons, and those statistics are better for the interpretability of the results, and is a team that has a high performance and has a few missing data points, so that is better for the purpose of this entire analysis. So I have created a chart on the right, so you can see the weekly series of goals scored from Barcelona. So you can see that there are some missing pieces over there. Mostly the missing pieces of data that we have are when the leagues are over. So there's breaks at the middle of the year and at the end of the year. And on those specific places, we need to have some data. And for this, I used linear interpolation for the missing values. And that will allow me to avoid problems with the modeling functions, and also to maintain the seasonality of the series. So moving on to the transformations, on the original series that I have on the chart, I have the goals per match for the FC Barcelona in the entire time frame. I do have some variability of the data, but there's no clear trend. I mean, some matches have a lot of goals, some have not. So I run a stationary test, the ADF test, and we can see that the ADF statistic value is minus 6.0693, and the p-value is 0. And as it is less than 0.05, the series is stationary. And there's no differentiation required. So I can conclude that the original series is indeed stationary. So moving on, I have applied both the ACF and BACF analysis. So starting with the ACF for the original series, there's no clear cutoff in any part of the chart. So there's no MA component for the series. And for the BACF, we can see that at lag number 1, there is a major cutoff, which suggests that we can use a AR1 model. So creating the model for ARIMA, it is going to be a 1, 0, 0, and the components are the first number, which is 1, is due to the cutoff that we have on lag 1 on the BACF analysis. And then as we did not apply any differentiation, the second number, which is the D, is going to be 0, and also another 0 because there's no need for a moving average in this analysis. I have trained the model with the entire series except for the last 10 matches because those are used for the training itself. So the evaluation is for the last 10 matches. We have on the right, we have the chart that shows the actual number of goals that was scored, and in the green line we have the forecast, which is the prediction. And on the metrics we can see RMSA 1.275, MAA 1.124, and MAPAE 55.76. So the average error is around 1 goal, and the MAPE, which is 55%, a little bit above 55%, it is high, but in low magnitude series like this one, it's common for small errors to represent large percentages. Moving on to the conclusions, the AR1 model captures part of the dynamics of goals per match. The MAPE is high because the number of goals is small, so any deviation has a large percentage impact, and the absolute metrics indicate an acceptable average error of about 1 goal per match. As I mentioned, I used data interpolation to fill the gaps caused by breaks, either summer breaks or winter breaks, but this could be improved with more robust techniques. And then the goals per match series for FC Barcelona was successfully modeled using a simple and interpretable AR1 approach. The interpolation helped to maintain the temporal structure without introducing obvious noise. And I would say that as a future improvement, I could consider exogenous variables that could be incorporated and compared with more complex models. Overall, I will say that the practical value of all of these analyses that I made for the goals scored by the FC Barcelona in this time series is that this model can be used to forecast the overall performance of the team, and this analysis can support scouting, betting, or other technical planning, and it will be useful for those matters. So that's it for the presentation. Thank you very much for watching, and I wish you all good luck in this course.